So the last problem here is missing number, and it's part of bit manipulation. It's an easy problem, so we'll look into it. So we go to LeetCode.com/problem/missing number/description. So 268 missing number. Given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. Interesting. So we have basically an array of nums containing n distinct numbers. So they're all different in the range from 0 to n. And we have to return the only number in the range that is missing from the array. So we have a nums list which has 0, 3, 0, 1. And we can see that 0, then 1, then 2, and then 3 happen, right? So 2 is missing, so we could say 2. Explanation, n is equal to 3. So containing n distinct numbers, yeah. So basically the size is 3. Since there are 3 numbers, so all numbers are in the range 0 to 3. 2 is the missing number in the range since it does not appear in nums. Alright, so now we're going to do the next process. Where is the next example? And in this example 2, we have nums 0 and 1. Now over here we have the output as 2. Because n is equal to 2, since there are 2 numbers. So all numbers are in the range 0, 2. 2 is the missing number in the range list since it does not appear in the nums. Okay, again over here we have nums. And now what is the output? 8, because we don't have it. So you kind of understand here that we have a nums list, we have 0 and 1, and we don't know that n is equal to 2 since there are 2 numbers. So all numbers are in the range. 2 is the missing number in the range since it does not appear in the nums. So over here we just get the size 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is it? N is equal to 9. Since there are 9 numbers, so all numbers are in the range 0 to 9, and what number is missing is 8. So you detected 8 is the missing number in the range since it does not appear in nums. Now we have this constraint that n, which is the number, should be the nums length. So nums.length, nums is basically this list, it's less length, so it tells you how much numbers are in there. This number n the length should be within 1 to 10 raised to the power 4. That's a lot. And then we have over here, which is num sub I, the number should be between 0 and n. So n basically means the last number, right? That's 9. Basically it means the size, so whatever the length is, and it should be equal to or less than the size, the number within the list. Got it? So all the numbers of nums are unique. That's one thing about it. Could you implement a solution using only O1 extra space complexity and O1 runtime complexity? Well, this is a challenge that I want you guys to solve in the comments. That when I make this solution, you have to make it even better and try to do it with O1 extra space complexity, meaning it's not taking any space, it's doing all of it in line. And O1 runtime, meaning it's linear in runtime. Okay, so now that we have this, let's quickly solve this because this seems pretty easy. Now what we have here is an int return type missing number, and we have a vector of ints, and it's called nums. Okay, and we have to find the missing number. Interesting. Let's get the n size first. So what is the size? You see that it takes out the size, like n is equal to 3. How do we get this? We get the length of this vector. So we could say nums, which is the vector, dot size function, and this just gives me the size of the vector, and I could just put it as the n, right? Like int space n is equal to nums dot size. Now what we have here is we want to find the total sum from 0 to n. So if I could actually count this up, this is like an approach. If I count this from 0 to n, basically how much is the sum? We have 1 plus 0 plus 3, and that's 4. Now, okay, that's 4, and then if we know that there's a missing number, we could actually find it using a formula. And basically that was 4, the missing number is 2, so if we divide, we get 4, and then we basically get it divided by 2. That could actually result in 2, right? But if I have this 1 and then I divide it by 2, that's not actually the output. Maybe I have to multiply with 2 and then divide it by 2, because if I have 4 and then multiply with 2, which is 8, 8 divided by 2, which is 4, but that's not corresponding either. So we're going to have to find a formula here. So suppose we have this number n, which is the total count, or maybe it's like that. So essentially we have 4, which is the sum. How much is this? 3. So essentially this is going to be 3. If I have 3 plus 1, that's 4. Okay, I'm looking at the first example right now. I'm just looking at the first example. So that's 4. And if I multiply it with 3, so 3 multiplied by 4, how much is that? 3 multiplied by 4 is actually 12. And then when I divide 12 with 2, so this actually means that I could just put this in a space actually. Okay, so 12 divided by 2, which means 6. Okay, and this is going to be the total sum. Okay, so we have the total sum from 0 to n. If I really count this, this means the number 1 with 0, which is 1, plus 2, which is 3, and then which is 3 again, 6. So we kind of like add the missing number as well. So we get the total sum, which is 6, right? Now we get the array sum, the current array sum. And I could get that array sum using a for loop. Really simple. Just get each number using a range-based for loop and say, okay, for each number from the nums vector, you could array sum plus equal to number, just like this. This is gonna add all the numbers one by one inside. What you could do afterward is just simple math. You have the total sum you found, and then you basically counted the entire array and found the missing. Then you could just subtract it. Return the total sum minus the array sum. And you could simply return this answer, and that would be your missing number. And we'll basically dry run it, but first of all, let me just run it. So control and comma. And it accepted, so like all the test cases were correct. We have case 1, which is 301, output is 2, and expected was 2. Case 2, which had this, output was 2, and the expected was 2. And the last one, which is this, the output was 8, and the expected is 8. Okay, so let's just dry run it with one more example so that it makes more sense. Let me just go up here. I'll bring it down. Okay, so now over here, how we could dry run this is essentially have this number 301 or 01, or basically this number. So let's just talk about this one, simple one, and suppose this is our question. Okay, now let's dry run it using this number. So this vector lists nums, it's 0 and 1. Now we get the nums dot size, which is 2. We put it in n. Then we got the total sum. Now the total sum is actually, it's pretty simple. We'll get the total sum of the entire length, and then we essentially divide it. So this is common math. We get the number, we add it with 1. So suppose the number was 3, right? There was 3 was the total length. So this was 0 and 1. There's always going to be one number missing. That's the reason why I have to add 1. You understand? That's why. We have to add 1, and then we multiply it with itself. So right now, how much was it? 2 plus 3, 2 plus 1, which is 3. 3 multiplied by n, which is basically 2. So 3 multiplied by 2 is 6, and 6 divided by 2 is essentially everything, whatever the result is, you divide with 2. So 6 divided by 2 is 3. So essentially you got the total sum as 3, and that means like 0, 1, and then the missing number, which is 2. If you sum it all up, it's essentially 3, right? So what you do is you get the array sum, which is the current sum, which is 1. 1 minus, so you say, okay, 1 is over here, and 3 is over here, right? 3 minus 1 is 2, and that's the missing number. I hope you understood this. Try dry running it yourself. It's always good to have it tested, and once you do, you basically could have a complete solution. And there you go. That was the solution for this problem. Hope you liked this video.